Last thing we have to look at in this unit is systems of inequalities. At this point, you are an expert when it comes to systems of equations. You really are an expert because you did awesome yesterday. The last thing, though, is systems of inequalities. We looked a little bit at these at the very beginning of this unit when we talked about solution points for systems of inequalities. The focus of this lesson is going to be on two things. It's going to be on how you graph a system of inequalities and then interpreting them. So if I give you a graph, what is it saying? What does it mean? So to start us off, we're going to look at this situation here. It says to make a quilt, a quilter is buying fabric in two colors, light and dark. He needs at least 9.5 yards of fabric in total. Just want to pause right there. It says he needs at least 9.5 yards of fabric. We've learned at least is a sign that it's an inequality. What does that mean if he needs at least 9.5 yards?
That's the minimum.
Mm-hmm.
So it would be...
I see you eyeballing the graphs. It's the minimum, so he needs at minimum 9.5 yards. So he needs 9.5 yards or more. So for example, he could have 5 yards of each. That would meet this requirement. The other thing they tell us is the light color costs $9 a yard. The dark color costs $13 a yard. The quilter can spend up to $110 on fabric. That idea of spend up to $110, that's another clue that it's an inequality. What does that mean if you can spend up to $110?
Means cannot go over that.
Good. It can't go over 110, so it has to be 110 or less. Perfect. I've already gone and graphed both of these things for you. We've got this one here is the length requirement. So that was that first part that says he needs at least 9.5 yards in length. And then this other one here is the cost requirement. We've seen graphs of inequalities before. One of the things I notice is it's got this shaded area here. It makes it different from equations. What is this graph telling us?
It's saying that there's a certain amount that you have to give.
Mm-hmm.
Because the larger, or the area over the line
Mm-hmm.
is shaded in.
Mm-hmm. So what's this shaded area here telling us?
That means any point in that area would be an appropriate length requirement.
I like that. That's such a fancy way to say it. Any combination of numbers here, any point here would be an appropriate amount of fabric for what he's saying. He's saying he needs at least 9.5 yards. Any point in here satisfying that requirement. So just like real quickly looking at it, give me a possible combination. 8 yards of fabric for the light one, 2, that would be this point right there. I agree, because it's in the shaded area. We've got this cost one here, similar to my question before. What is this graph here telling us?
Saying that you can spend no more than $110.
Mm-hmm.
So the area that is shaded in, which is below the line,
Mm-hmm.
is how much of each fabric you can get without going over the cost.
I couldn't say it better myself. Yep. So the area, you said the shaded area here, this area below the line, is a combination of how much fabric you can buy for each color without going over that cost of $110. So again, like just looking at it, give me one possible combination he could buy.
Like 4 and 4.
4 and 4. Because 4 and 4 is in the shaded area. A different question real quick before we move on. You said 4 meets that cost requirement. Would 4 have met the length requirement?
No.
How do you know?
Because, well, with the length requirement, you need to have at least 9.5 yards.
Mm-hmm.
And 4 and 4 makes 8.
Yep. So what I like is you went back to what they told us here, and you're saying, I know you need at least 9.5, and that's not going to cut it. Is there a way you could have answered that question using something else?
Yes. Well, I'm sure there is.
Maybe that's the direction we're going. Okay. I'm going to jump. There's a couple different questions we're going to answer using this information here. The first question, which is down there at the bottom, says write an inequality to represent the length requirement. Let X represent the yards of light fabric and Y represent the yards of dark fabric. So I've left all this information here. I left the graphs here. And I'm just going to keep changing out the questions down here. So we're writing an inequality for the first part, for this length. Do you have an idea what that inequality would look like?
Could be like L plus D is greater than or equal to 9.5.
So let's talk through how you got this. Tell me first where L plus D it came from.
So L is the light colored fabric and D is dark colored fabric. Well, it's the amount that you get.
I like how you reworded that too. So the amount of light color fabric, the amount of dark color fabric, and we're adding them because
we need at least 9.5.
And I can see your eyes coming up here. At least 9.5 yards of fabric in total, which is helping us know we want to add them. The one thing I would change about what you've got written here, read through the question again and see if you can find what I see. Read through part A.
So it'd be X plus Y.
There you go. Because they're telling us to use X and Y, we're just going to switch them out. But I like how you did a real great job of saying X is the amount of light color and Y is going to be the amount of yards for the dark color. We've got our inequality here. The next question I've got is select all the pairs that satisfy the length requirement. So I've got 4 pairs of points here. Again, we've got the information up here. We've got the graphs. We now have the inequality you wrote. Let's start with this first one. Does 5, 5 satisfy the length requirement?
Yes.
How do you know?
Because you need 9.5, and 5 and 5 would be 10.
So you're looking at, it looks like you're looking down here.
Mm-hmm.
So you're using your inequality. Is there another way we could have checked to see if this point satisfies the length requirement?
Use the graph.
How could we use the graph?
And then find 5 and then the other 5 and then find the point.
Mm-hmm. So 5, where would 5 be?
In between 4 and 6.
Mm-hmm. Good. So 6 there, so 5's right there. And then same thing up here. 5 would be right there. So what do we see?
It does satisfy the length requirement.
Yep. So we could say this one satisfies. You could also go back up to the words up here. If he needs at least 9.5 yards, sounds a lot like what you were doing down here. We can just add them to make sure it's at least 9.5. What about this next one, 2.5 and 4.5?
Does not satisfy the length requirement.
Why not?
Because 2.5 plus 4.5 is 7.
Yep. So when you add them, you get 7. That's not at least 9.5. Keep going.
That one does.
Mm-hmm.
And then the last one does also.
Okay. You were doing those pretty quickly. I think based of just seeing where your eyes were going, you're using this each time. Okay. So, quick review. One way you can check to see if a point is a solution point is by, what have you been doing this whole time?
Going back to the inequality.
And
Substituting.
there you go. Using substitution. We've got a similar question coming up for the second part of this, which is, what about the cost requirement one? Let's do the same thing. So for the cost requirement, can we write an inequality to represent that?
It would be 9x
So you'd already told me earlier the less than or equal to 110. Tell me where 9x and 13y are coming from.
Because x would be for... Yeah, x would be for a yard of the light-colored fabric, and then y would be a yard of the dark-colored fabric. And then so it'd be... Or would be the amount of each one, yeah.
Yep. So the cost of 1 yard times how many yards you're getting. The cost of 1 yard times how many yards you're getting. So we've got our inequality here. Similar question to what you were just doing a moment ago then. Is tell me if these pairs here satisfy the cost requirement. I keep writing that. I'm going to put it over here. So same thing. We've got the problem. We've got the graph. We've got the inequality. I've got 4 points, and we want to know, do they satisfy? The 0.11?
Yes.
How are you figuring it out this time?
By looking at the graph.
Why did you switch? Because last time I saw your eyes, you were just using that inequality the whole time. Why are we switching to using the graph out of curiosity?
Because the variables have numbers with them.
Could you use this?
Yes.
Absolutely. One of the reasons in math we've got so many different ways to represent the same thing is because depending on the situation, one way might be easier than another way. You've got the story problem, you've got the graph, you've got the inequality. They're all saying the same thing, but I agree. That last one, it was a lot easier because it was just x plus y, but now that there's more math to it, the graph might be easier for us to look at. What about 4, 5?
It does.
If I asked you to justify one of these, tell me how you would justify that point satisfies the cost requirement.
Because on the graph, you can go over 2, 4,
Mm-hmm.
then you can go up to 5, and it will still be in the shaded area.
I agree. What about 8, 3?
It does not.
You sounds like you have a question mark in your voice.
Well, 8 times 9 is...
So we're coming back to the math now. Okay. So I heard 8 times 9.
That would be 72.
Mm-hmm.
And then 13 times 3 is 39.
Mm-hmm.
So, well, no, so it would be 111.
It would be. So we would get 111. Is that less than or equal to 110?
Is greater than 110.
So what's that mean about this point?
Is not correct.
Good. Tell me why you were starting at the graph. You did those first two at the graph, you started looking at the graph, and then you switched over to doing the math. Why was that?
Because that point is very close to the line, but it's not right on it, so you can't really tell from the graph.
Exactly. When it comes to graphs, I think a downside of graphs, especially when the scale is like this, is it's really hard to see those points that are close. For example, on our y-axis, that y-intercept is really close to 8. I don't know if the camera's going to pick that up, but it's not exactly at 8. It's a little bit higher. So if I were to ask you, what's the y-intercept of this graph? This is going to be one where you're not going to be able to figure it out looking at the graph. We know it's a little more than 8, but how much more, we don't know. So I liked what you did where you started here and you're like, it's going to be really close to that line. And then you switched over to using something else. I think that's great. What about this last one here?
That one is not correct.
Tell me why.
All right, no, it is. No, never mind. Yeah.
Tell me why it is correct.
Because on the graph,
Mhm.
go over 10,
Mhm.
go up 1,
Mhm.
it is in
Yeah.
the area.
The shaded area. And if you were unsure, we could always come back here and do the math. 9 times 10 is 90. 13 times 1 is 13. And that's going to be less than 110. Nice. So this first part here is really focusing on, can you identify if something is a solution point? The second part to this is looking at it all together. So I've got the question, explain why 2, 2 satisfies the cost requirement, but not the length requirement?
Because it is within the shaded area for the cost requirement, but it is not for the length requirement.
Perfect. So if we come over here, 2, 2 is right here, not in the shaded area. Here, 2, 2 is in the shaded area. What does the point 2, 2 represent in this situation?
2 light fabrics and 2 dark fabrics.
Yep, 2 yards of each of the fabrics. So it means if I were to buy 2 yards of each of the fabrics, am I getting the amount I need? Am I staying within my budget?
Yes.
Yep. So we wouldn't have enough fabric, but it would be cheap enough. Here's the last one. The last question is find at least one pair of numbers that satisfies both requirements. And then you're going to explain to me how you know. As you're trying to answer this question, I already saw you make a tiny bit of a face. Tell me what you're thinking. Like, what are you looking for?
I guess I'm just kind of looking at the graph right now and looking for certain points that are on both lines, or that are in both shaded areas.
Okay. So looking at both graphs, trying to find a point that's in both shaded areas.
I can see 8 and 2.
8.
Both the shaded areas.
8 and 2. 8 and 2. Nice.
So yeah, 8 and 2.
Mm-hmm. I asked for at least one pair of numbers. Could you find more, maybe?
Like 12 and 0.
12 and 0. 12 and 0. Just barely there. So your eyes are just kind of, I see them. They're just going back and forth, back and forth. Would there be an easier way for you to find these points?
Probably, yes.
Do you have anything in mind?
Getting both inequalities and then doing the math on them.
Getting both inequalities and doing the math?
As in like elimination.
Oh.
Or
Oh, I see.
maybe.
Okay. So you're thinking back to like what we were doing with systems of equations?
Mm-hmm.
Nice. When you are solving system of equations, for the majority of them, how many solution points are there?
1.
1. How many solution points are there for an inequality?
There could be multiple.
Many. So I like what you're thinking. I'm so glad you brought that up because it wasn't something I was thinking about. But the difference is when we're using those 3 methods, you use those methods to find that one solution point. Anytime you've got something like this where there's many, there's no way for you to solve and get an x and a y when there are so many x's and y's. What a great idea. I'm thinking about something we could do with the graphs to help make it easier for you. Because I saw your eyes, they kept going back and forth, and you found these pretty quickly. I did this with someone else, and it took them much longer of going back and forth, back and forth, back and forth. Do you have an idea with something we could do with the graphs to help us?
Use one of the lines, or just put both lines on one graph.
Put both lines on one graph. I love it. Guess what? That's exactly what we're about to do. I'm going to exit out of our PowerPoint, and I'm pulling up this here. So this is a website. I've already typed in both of our inequalities you came up with earlier. So I can turn on one. I'm going to move it down a little bit so we can see all of it. That would be helpful. There it is. So I can turn on one. That was the first one we were looking at. There's the second one we were looking at. But wouldn't it be helpful if we did exactly what you just told me and put them both on at the same time? If we're looking at both of them at the same time, where are those solution points going to be?
In the area where both shadings are together?
Yep, that area where it's both shaded. So this red area and this blue area are overlapping right here. We use that word overlapping a lot to describe this. So now that I'm showing you this, I'm going to ask the same question. Can you give me some solution points?
10 and 1.
10 and 1, perfect. What else?
6 and 4.
Perfect. What else?
7 and 3.
7 and 3, perfect. See how much easier it is when they're on the same graph? Congratulations, you have found the main purpose of this lesson. The main purpose is anytime you're talking about multiple inequalities at once, when we're looking at the graphs, this is the easiest way to look at it. We were doing all those previous ones separately, and a lot of those questions, if I'm only asking about one of the requirements, it's fine that they're separate because we're not looking at them together. But when it comes to being a solution to the system, it is going to be easiest for us to look at the graphs at the same time. Now, when it comes to the solution points to the system, so when it comes to the combinations of fabrics she can buy where she meets that length requirement and she's under budget, would any points over here be a solution to the system?
Mm-hmm.
Why not?
Because it only meets one of the two requirements.
Nice. I don't know if the mic's picking up, but he said it only meets one of the two requirements. Same with over here. It's only meeting one of the two requirements. So when we are actually graphing these, when you go to shade, you are only shading the solution points to the system. What would that mean we would want to shade if we were graphing this by hand?
What we're going to shade?
Mm-hmm.
You're going to shade.
Your hand speaks so much. Just that overlapping area right there.
Yeah.
Because that is the only part that has the solution points. So this wouldn't be shaded, and this wouldn't be shaded. Nice.
Oh, yeah.
Is it starting to come back? Okay. So I mean, you've got it. That's the main purpose of this lesson, is talking about what those graphs would look like. So I've got this part here. We're gonna summarize some things you already knew from graphing inequalities in the past, and then this new part you just told me. Great job with that.
Thank you.
I can't imagine you're a quilter. I wish it was more applicable, but it was a good question. So what we learned back in Algebra 1A was two things about graphing just a single inequality. We said that when you're graphing inequalities, we had to decide on a line to use. For a less than sign or a greater than sign, do you remember what we called the line that we would use for those?
Dotted line?
Yep. So we would use a dotted line or a dashed line, whatever you prefer to call it, but it looked like that. And then for the less than or equal to or the greater than or equal to, that would be a
solid line.
Nice. Which is the line we're used to using. Both of our inequalities in that last one had these, which is why we were using solid lines. Then for the shading, I already heard you using some of these words when you were describing it earlier, but for those less than signs, you would shade
Below.
Yep. We shade below the line, and then for the greater than signs, it's shaded
Above.
Yep. This piece right here is the new part. When you are graphing a system of inequalities, all of this is still true, but that final shaded area would be that overlapping part. It's the part of the graph that would have been colored both times had we done it like we just saw on the graphing calculator. So we're moving away from the quilting questions, and instead we're just going to look at two inequalities on our coordinate plane. Those two inequalities that you and I are going to go through are these ones right here. And number one, we've got y is greater than 2x, and then 2y minus 3x is greater than or equal to negative 4. If I wanted to graph this system of inequalities right here, what would you want to do first?
So for y is greater than 2x, would the y-intercept, is there y-intercept?
I don't know. Tell me what you're thinking.
I don't really know.
Where do you normally find the y-intercept?
On the opposite side of y.
So over here. Is this the y-intercept?
No.
What is that?
Slope.
Is there another number here?
No.
So if there's no number, what?
Y-intercept is 0?
Yep, you got it. You can think of it as like there's an invisible plus 0 right there. Adding 0 doesn't do anything, which is why we don't need to write the plus 0. But our y-intercept would be 0. What you want to do next?
And slope is 2.
Mm-hmm.
So you go up 2 over 1
Yep.
each point.
Rise 2, run 1, again and again.
And then I guess you could also go down 2 and then back 1.
Yeah, let's be good. Okay.
And then for the second one, you need to get the y by itself.
Okay. Nice. So for this one, I feel like this is always, hold on. Let's do it. Get the y by itself. How are we going to do that?
Yes, add 2 or 3x on both sides.
Yep. What's that going to leave us with?
Would be 2y is greater than or less, greater than or equal to
Mm-hmm.
-4 plus 3x.
Mm-hmm.
And then from there, the y, and there is a y intercept, -4.
Mm-hmm.
And then the slope is 3.
Now pause real quick. You told me you wanted to get y by itself.
Oh, yeah. So from there, would you subtract 2?
What type of math is happening in between 2 and y? Mm-hmm. So if that's multiplication.
So it needs to be division.
Yep.
So you subtract.
Well, you just told me division.
Divide by 2.
Mm-hmm.
And then do you divide the whole of the side by 2?
Yep. Mm-hmm.
And then so it's y is greater than or equal to -2 plus 1 over 2x.
Tell me how you're getting that.
3 divided by 2 would be 1 and 1 over 2. X.
Okay, yep. So 3 over 2 does equal 1 and 1/2. So I'll take away this for a second. The number that we're going to write right here, what does that number represent?
3 divided by 2.
What does it represent in terms of our line that we're about to graph?
The slope.
The slope. What is going to be the most helpful way to write the slope?
That's a fraction.
Mm-hmm.
So, okay. So yeah, it would just be 3 over 2.
Yeah.
Okay.
I don't want to take this away from you. That is great that you know that. That is absolutely correct. But 1 and 1/2 isn't really going to help us with our rise over run.
Yeah.
Same as if you were going to tell me a decimal. You could also say 3/2 equals 1.5. That is also correct. But it's going to be difficult to use that for rise over run. So we'll just keep it 3/2. You already told me this is our slope. You want to finish graphing it now?
So you start at -2,
Mm-hmm.
and you go up 3 over 2 each point.
Yep. And then I could always do the opposite, down 3 backwards 2. Ooh, and I can't do it anymore. Okay. When we go to graph this, I would generally say let's draw the lines first before we start plotting other points. This first one here, what line should we draw?
It should be dotted.
Mm-hmm. Ooh, okay. And then our red line.
Be solid.
Okay. We are done?
No.
Why not?
Need a shade.
Okay. So when it comes to shading, where am I shading for this first one here?
Above.
Mm-hmm. So it would be all of this. What about the red line?
It would also be above.
So it would be all of this. Which part of the graph was shaded both times?
The large area.
Yeah.
The area of.
You're right.
Well, yeah, it's all that. I can't.
Mm-hmm.
I guess.
Is there anything? Yeah. Is there anything, let me change the question then. We said earlier we only want to shade the overlapping part. Right now I've got a lot of stuff shaded. Is there anything I need to erase?
The areas that are shaded in but do not overlap.
Okay. So for here, where would that be? You said this big area here is all shaded.
The area between the blue and red line.
Yeah. So this part right here was only shaded with red. So that would not be a part of the overlapping area. I extended this down here. If I had kept going, we could see that that part would have only been blue and not red. So this little triangle right here would also be erased. It would just leave you with this big area here. You can leave it looking very patriotic, or we could just color it in to show that this right here is our solution, our set of solution points right there. So beautiful. How you feeling?
Good.
It's a lot of the same stuff we did back in Algebra 1A. We're just putting it together into one big fun problem. I'm going to have you try number 2. I'll let you decide, do you want to do it on the board or on your paper? It doesn't matter to me.
Let's do it on the paper.
Okay. I'm curious what you're doing with that first inequality. How did you graph the y is less than or equal to -1?
Well, the y-intercept is 0.
Why is that?
Oh. Oh. So the y-intercept is -1 and there's no slope.
Okay. So the y-intercept is -1. Why isn't -1 the slope?
Because there's no x next to it.
Nice. So it's by itself, no x, so that's our y-intercept. There's no slope. What's that mean about the line?
That means it's going to be horizontal.
Nice. Yep, horizontal, flat line, something like that. So it's a horizontal line running through -1. Be careful with this division here. So you're right, you want to subtract x on both sides. You're right, you want to divide by -2. Let's start over here. 2 divided by -2. Negative x divided by -2. I like the positive. What number is right here?
1. So 1 divided by 2 is 1/2.
So we got 1/2 right there. And then the last part, when you are dividing inequalities by negatives.
You flip them?
Yep.
Oh, okay.
Now it should be all good. So I'm going to catch up to you real quick. You already told me this is going to be a horizontal line going through -1 since there is no slope. This one we ended up solving. The tricky parts on this one is that idea of x divided by 2. If you think of it as like a 1 in front, it helps you see it's 1/2. And then it's a quick review when we're dividing inequalities by negatives. That inequality sign should change. So we're left with y is greater than 1/2 x minus 1. Starting at a -1, going up 1/2. What line am I going to draw through these points?
Dotted.
Okay. And then the final question, where do we want to shade for this?
Below the blue line and above the black line.
Below the blue line, so that would be all of this. And then above the black line would be this little wedge here. We've got below blue, above our black line, so I agree it would be that little bit right there. If it's hard for you or people at home for you to find that overlapping part, a strategy you can always do is kind of like what we were doing with that website, kind of like what we did over here. Just shade everything and then see where you shaded both times. So if I did what you verbally told me to do, you said it needs to be under the blue. That's all of this. Just by doing that, that tells me that final area should be either this triangle or like this big rectangular piece. It shouldn't be one of these because they weren't shaded. And then when we do the black, you told me the black shade above, that would be all of this. That also might help some people see that that right there is the overlapping part and nothing else should be shaded. Nice. How are you feeling about these?
Good.
There's one last one we're going to look at. We've got, hold on, we've got a messy board to clean. All right. For this last one, we have got a family has at most $25 to spend on activities at Fun Zone. It costs $10 an hour to use trampolines and $5 an hour to use the pool. The family can only stay less than 4 hours. The first question asks, what are some combinations of trampoline time and pool time that the family could choose given these constraints here? I've got my note here that says, yes, of course, you could do some trial and error, guess some numbers, see if they work, but let's utilize all these wonderful things you've learned today. So I've given you a graph over here. Before we graph anything, what do you think we want to do first?
Make inequalities.
Yeah, write our system. So I'm given all of this information here. When we go to start writing our system of inequalities, tell me what you're thinking first.
One of them could be like 10x plus 5y is less than or equal to 25.
What does this inequality say right here? How does this relate to the problem, I should say?
Well, x would be hours at trampoline.
Hours at the trampoline.
And then y would be hours at pool.
Hours at pool. Okay. So then this right here says Mm-hmm.
plus $5 per hour at the pools is less than or equal to $25.
Yep. So it's basically saying this is the money we're spending, and it has to be less than or equal to the money we have. So kind of like, well, there was one we did yesterday. This one here is describing the cost. What's the other inequality we can write?
Could be x plus y is greater than or equal to 4.
X plus y is greater than or equal to 4. Tell me where this one's...
less than or equal to 4.
We're changing it less than or equal to 4. How are you getting this one?
Because it's trampoline hours plus pool hours cannot exceed 4 hours.
Uh-huh. Now you said cannot exceed 4 hours, and if that's what it said, cannot exceed 4 hours means 4 or less. Come back to the story. This is almost like an English lesson because it didn't say can't exceed 4 hours. What did it say?
Can stay no longer than 4 hours.
What exactly does it say?
Can stay less than 4
Yeah,
hours.
they can only stay less than 4 hours. So if they were to stay equal to 4 hours, is that needing this?
No. So there'd be no or equal to.
Yep. Like I said, it's like an English lesson, which is out of my comfort zone. But we gotta, what you hit on is a difference in language. I could say no more than 4 hours, that would have the or equal to. I could say can't exceed 4 hours, that would have it. But this specifically says it has to be less than 4, which is why it's less than 4. Nice. So we've got our inequalities. You defined our variables, which we love. If I check, notice you said X is hours at the trampoline, and our X-axis is also labeled hours on trampoline, which is perfect. Same for the Y. Once we've got our system of inequalities, how can that help us get to the graph?
You could use the inequalities to graph the graph.
Yeah.
Or else to make the lines bigger.
Perfect. Where do you want to start?
You could start with either, but the second one is probably easier.
You want to start with the second one then?
Yeah.
Okay.
So, your y-intercept is 1.
Y-intercept is 1. How are we getting that?
Because it's just x plus y, and when there's no number in front of x or y, it just means 1.
Okay. Think back to what you just did. You're still looking at it. Look at the inequality you just graphed.
Oh. Okay, but you need to get x by itself or y by itself.
Which one, X or Y?
Y.
Yep. It goes back to slope-intercept form, that y equals mx plus b. We need y by itself first. Don't let the inequality signs throw you. It's the same idea. So if I want to get this in slope-intercept form, if I want it to look like this.
Okay, so you just subtract x from both sides.
Yep. Which is going to leave us with...
Y is less than 4 minus x.
Yep. You could write 4 minus x. You can write negative x plus 4 if you want it to look exactly like this. Either way is good. Do you want to change both of them, or you want to go ahead and graph that one?
We just do that one.
Uh-huh.
And so the y-intercept would actually be 4.
Very nice.
And then negative 1x. So the slope is just negative 1.
Mm-hmm.
So you go over 1 and down 1.
Yep. And I can keep doing that. Perfect. Anything else you want to do?
And the line would be dotted.
Love it. Notice in this problem I only gave you this quadrant of the graph. Those ones we were just doing had all 4 quadrants. Why is that? Was that a mistake on my part?
No, because you cannot be there for negative hours.
Yeah. If we kept going with those negative ones, negative hours on trampoline, negative hours in a pool, which is impossible. All right, so you got our first one for us. Second one?
The second one, you need to get y by itself again. So,
Wouldn't it be nice if I gave myself more room?
you need to subtract
Yeah, I'm gonna give us a little more room. You said subtract 10x on both sides. What's that leave us with?
5y is less than or equal to 25 minus 10x.
Love it. Anything else?
And then need to get rid of the 5 from the 5y.
Mm-hmm.
So you divide both sides by 5.
Mm-hmm.
And that would give you 25 divided by 5 would be 5. And then negative 10 divided by 5 is negative 2x.
Mm-hmm.
And then y is less than or equal to.
Perfect. So if I graph our second one, that's going to look like...
Start at 5,
Mm-hmm.
and then go down over 1 each point.
Okay. And then for our line...
It's solid.
Are we done? Is it beautiful?
Needs to be graphed.
I graphed it. What are you talking about?
No, it needs to be filled in. Or
What do you want me to fill in?
the 2 areas. And the 2 areas are... What was the equation?
That would have been real nice if I left that for you, wouldn't it? It was x plus y needs to be less than 4.
Oh, okay. Well, it's still the same symbol. So for the black line,
Mm-hmm.
you shade below.
Mm-hmm.
And then for the red line, you shade below as well.
Mm-hmm.
So the total area that you shade is just all of below the red line except for where it stops at the, or where the black line
Yeah.
intersects.
I like how you explained that. Everything below the red line except for... We're going to stop right there. Why can't I shade this little part here?
Because it's not part of the black line. So.
Beautiful. So we've done it. We've got this beautiful graph. What are some combinations of trampoline time and pool time that the family could choose given these constraints then?
Like 1 and 2.
Mm-hmm.
2 and 1.
2 and 1. Mm-hmm.
3 and 0.
3 and...
0 and 3.
0 and 3. Yeah, we can see all of them now. Also hours, remember, it doesn't have to be like a whole hour, so you could do like 1.5 hours somewhere. So these last 2 questions should be real easy now that we've got this graph. The first one, can the family spend 1 hour on the trampoline and 3 hours in the pool?
Yes.
If I asked you to explain to me how you know that?
Because on the graph, you can go over 1 and then up 3.
Mm-hmm.
And you would still be within the line, or within the shaded in area.
Now I'm curious, that's not in the shaded area. Where is that point?
No, it's actually over the red line. Is it?
I wish I had a ruler. It's on the red line and it's on this dotted black line there.
Oh, so that does not work because you cannot exceed 4 hours.
So what I hear you saying is, you're going back to the story. This means we can't be...
No, you cannot even get to 4 hours.
We can't be at 4 hours. It has to be less than 4 hours. So what do you notice about that point? That point we said wasn't actually in the shaded area. It's on
The lines.
the lines. Would this combination, so we said it's not okay for here. Would it be okay cost-wise?
Yes.
How much would it cost?
$25.
Exactly
So
25.
it's on the black line, but is it on the red line?
It's on both lines. The red line was our cost. The red line, notice, is a solid line, and you figured out it's okay on cost.
Oh.
The black line was our time. It was on that black line, but we said it's not okay. So what's the difference? It's on both lines. Why is it okay for one and not the other?
Because they're not, they can spend $25, but they can't go over it. But with the 4 hours, they cannot even get to 4 hours.
So if I hadn't given you any of this information, if I just gave you the graph, how would you know that? What's the difference between those 2 lines?
One of them's solid, the other one's dotted.
Yeah. If a point is on a solid line, is that okay?
Yes.
Remember what you had said about the cost for that point on that solid line? You said it cost exactly $25. And here, it's okay if it costs exactly $25. It's okay to equal $25. If a point is on that dotted line, is that okay? Why not?
Because dotted line means you cannot get to the line or go over it.
Yep. It goes back, if you think back to Algebra 1A with our inequalities, when I was asking you to graph something like, let's say x is greater than 1 versus x is greater than or equal to 1, when it came to shading in that 1, for both of these it was shaded that direction, but we said if it can't equal 1, we would just use an open circle, and then if it could equal 1, we used a closed circle. It's the same idea here. We're using that solid line to show we are including these points in our solution. We're using that dotted line to say, no, I just need a line to show where the shading stops, but we're not including those points. And you can do what you did, which is always go back to this information here. But if there is no information, if it's just like an XY graph, no story, if it's on the solid line, it is a solution point. If it's on the dotted line, it's not a solution point. Awesome. What about this last one? Can they spend 2 hours on the trampoline and 1.5 hours in the pool?
No.
Tell me why.
Because they exceed their cost limit.
Ooh, how'd you know that?
Because it costs $10 to be with the trampolines for an hour, and that's 2 hours, that's $20. And then $5 for an hour at the pool. And if they go for 1.5 hours, it'd be like 27.
So you just did all the math in your head that quickly?
Yeah.
Do you know how you could get to that using the graph?
You go to 2 on the x-axis and then up to 1.5, which is also not in the shaded area.
Yep. It would have been if we had shaded remember we had shaded below the black line. So it's in that shaded area, but it's not in the cost shaded area. So you could also figure out what you told me from that. But this one would be a no. That is the last example I have for you. There are 2 on the bottom for you to try, similar to this, where you're telling me if something is a solution point or not. Oh, well, sorry. Let's fill this in real quick. I was getting excited. This is just a summary of what you just told me. So to summarize, when you're looking at these graphs of systems of inequalities, it is a point. A point is a solution point if it's in one of 2 places. One place it could be a solution point is if it is in the
Shaded area.
Yep. The shaded area. The other place it could be a point is if it lies on a
Solid line.
It's like you're the teacher. Solid line. If it was in the dotted line, that wouldn't be a solution point. Now we're done. So the last thing is these ones here. It's a similar question. I've just taken away the word problem. So you're dealing with some pure algebra. But the question's the same. It's, are these points a solution point? And people at home, this is the one for you to try. And that is where I leave you. Goodbye.